Hello everyone. So today I will talk about the assignment 3 week 3 previous year question paper for the course classical mechanics of a single particle. Okay. So let's start. Basically today I will talk about total 10 questions of the classical that assignment 3 previous year questions. And this is basically the week number 3 was basically for the central force motion, central force problem, as well as there was something like the force was given and you have to calculate the velocity and then the position of the particle like that. Okay, so let's start the question so that we can understand how we can proceed and what we can need to understand better. So this is the first question. A particle of mass 3 units has initial position vector r0, I cap plus 2j cap plus 3k cap, and initial velocity v0 minus I cap plus k cap. A force F equals to 3t square minus 4t I cap plus 2tj cap plus 5k cap acts on it. What is the position and velocity of the particle at time t equals to 2? Okay, so this is the question. Now, let me write whatever is given. First of all, mass is given, 3 units. Initial position vector, that means the initial condition is already given. So, these initial conditions r0 and v0 will be very much useful when we will do the integration, and then there will be an integration constant. To get the integration constant value, we need the initial conditions. So, initial condition is what? R0 equals to I cap plus 2j cap plus 3k cap. And initial condition means at t equals to 0 time. And what about v0? v0 is minus I cap plus k cap. And now coming to force. Force is 3t square minus 4t I cap plus 2t j cap plus 5k cap. So let me write here again the vector. Okay. So now they are asking that what will be the vector of the velocity at t equals to 2. What will be the position at t equals to 2. So how we can write? So we know F equals to m dv dt. That I know. Now I can write dv dt m. Actually we can write F by m. So v will be integration F by m dt. Okay. So I can write here 1 by 3. M was 3. So it is like integration F dt. So 1 by 3 integration. What is the integration here? 3t square. Maybe I can do one thing. 3t square minus 4t I cap plus 2t j cap plus 5k cap. This whole dt. Right? So if I write here 1 by 3, then integration was what? It is over on t. So it is like f dot dt. So f dot dt will be like, so this will come as v. So it will be like 3 t cube by 3 minus 4 t square by 2 I cap plus 2 t square by 2 j cap plus 5t k cap. So this will be the integration of these things, and there will be one simple constant c1. Okay. Now if I just simplify a little bit, then it will be t cube minus 2t square I cap plus t square j cap plus 5t k cap plus C1. Now we need to calculate the C1 value. So at t equals to 0, V was V0. So V0 was what? V0 equals to minus I cap plus k cap. So minus I cap plus k cap equals to 1 by 3. If I put 0, that means you can see all the terms will be 0. So only the C1 will left. So C1 is, actually this is a vector again, right? So C1 will be 3 into minus I cap plus k cap. So what will be our V vector finally? V vector will be 1 by 3. Then t cube minus 2 t square I cap plus t square j cap plus 5 t k cap minus 3 I cap plus 3 k cap. This is our V. Now coming to X, like R basically, position vector. So position vector, how we can get? So V vector I can write it as dr dt. So R vector will be integration V dot dt. So okay, now I can do one thing here, t square minus 2 t square, t cube minus 2 t square minus 3 divided by 3 I cap plus t square by 3 j cap plus 5t plus 3 k cap divided by 3. So this is the V. Now I just need to integrate this one. So t cube minus 2 t square minus 3 divided by 3 I cap plus t square by 3 j cap plus 5t plus 3 by 3 k cap whole dt. So it will be, I can see here, for I cap, j cap, k cap, it will be like t to the power 4 by 4 minus 2 t cube by 3 minus 3t divided by 3 I cap plus 1 by 3 t cube by 3 j cap plus 5 t square by 2 plus 3t divided by 3 k cap plus C2 vector. Now what is C2? At t equals to 0, R vector is R0 vector. So R0 vector is what? R0 vector was given by I cap 2 j cap 3 k cap. Okay, I cap 2 j cap 3 k cap. That will be, you can see all the terms are in t only. So f t equals to 0, that means all these 2 will left. 1, let me see, 1 2 3. Okay, fine. So C2 vector is this one. So now our R vector will be simply t to the power 4 by 4 minus 2t cube by 3 minus 3t divided by 3 plus 1 whole I cap plus t cube by 9 plus 2 j cap plus 5t square by 2 plus 3t, 5t square by 2 plus 3t by 3 plus 3 whole k cap. Now what is the question? The question was, as t equals to 2, what is the position and velocity? Okay. So at the very first velocity I can t equals to 2, velocity I can write. So you can see here, if t equals to 2, that means I have velocity is 8 minus, you can see here 8 minus 8 minus 8 will cancel out, so minus I cap plus 4 by 3 j cap plus 10 plus 13 by 3 k cap. So this is the velocity at t equals to 0, sorry, t equals to 2. Now coming to position at t equals to 2. T equals to 2, the position will be, if I will put t equals to 2, that means 2 into 16. 16 by 4 is 4 minus 16 by 3 minus 6 divided by 3 plus 1 I cap plus 8 by 9 plus 2 j cap plus 10, right, 4 plus 6 divided by 3 plus 3 k cap. So this will be minus 2 minus 16 by 3 by 3 plus 1 I cap plus 8 plus 18 j cap plus 16 by 3 plus 3 k cap. So this will be my r vector. So if I calculate these things, then it will be like minus 6 minus 16 plus 1 I cap, then it will be 26 by 9 j cap plus, it is like 3, 16 plus 9 k cap. Okay, so this is the answer. So it will be like minus 22 by 9 plus 1 I cap plus 26 by 9 j cap plus 25 by 3 k cap. It will be 3 only. Yes, it will be 3 only. Yes, 3, right. So it will be minus 22 plus 9 I cap plus 26 by 9 j cap plus 25 by 3 k cap. So if I just simplify a little bit, 13 I cap 26 by 9 j cap plus 25 by 3 k cap. So the final answer is 1 by 9, 13 I cap, 26 j cap plus 75 k cap. So this is the position vector at time t equals to 2. Okay, so the first question was this one. A particle of mass 3 units has initial vector r0 equals to I cap plus 2 j cap plus 3 k cap, and initial velocity v0 is minus I cap plus k cap, and force is given 3 t square minus 4t I cap plus 2t j cap plus 5 k cap. Action in, what is the position and velocity of the particle at time t equals to 2. And we got the answer. Velocity is this one at t equals to 2, and the position is this one at t equals to 2. Okay, now we can go for the second question. Find the work done by a force if 4t square plus 2t I cap plus 3t j cap on a particle moving along the velocity vector v. 2t I cap plus t square j cap from t equals to 0 to t equals to 3. So they are asking that what is the work done by the force, right? So what is the work done? W is integration F dot dr. Okay. So I can write it in this way, that dr dt dt. Yes. So it will be dr dt is nothing but it is a v. Then dt. F dot v dt. Now I have F, I have v. So I will just do that F dot v. So let me write here F and then v. So F is what here? 4t square plus 2t I cap plus 3t j cap, and v is 2t t square, 2t I cap plus t square j cap. So F dot v is 4t square plus 2t into 2t plus 3t into t square. So it will be like 8 t cube plus 4 t square plus 3 t cube. So 4 t square plus 11 t cube. So F dot v dt 0 to t. So W is nothing but F dot v dt, and I can write it 4t square plus 11t cube dt 0 to 3. And the answer is like 4 t cube by 3 plus 11 t to the power 4 by 4, 0 to 3. So if I write here 0, that means it will be all 0. So that means 4 into 4 by 3, 3 into 3 into 3 plus 11 by 4, 3, 3, 3, 3. So if you calculate these things, then it will be 36 plus 81 by 4. So 81 by 4, I am taking the calculator. 81 by 4 plus 36. Oh sorry, into 11, sorry, this is 11. So it will be 81 by 4 into 11 plus 36. 258.75. 258.75. So this will be the unit and of work done. So let me check the option. 258.75 means it will be 257, around 259 units. So how I did that? I have the velocity vector v, I have the force, and they are asking what will be the work done by a force. So what I did, F dot dr I did, and F dot dr means dr dt into dt, and F dot v dt, as F is given in terms of t, v is given in terms of t, so we will just do F dot v, and then F dot v in dt we will calculate, and then the integration will be from 0 to 3, t equals to 0 to 3. So the answer will be like 258.75 units. Okay? Yeah. So I'm just taking showing you the question again. So this is the first option, which will be the correct one. Okay. Now maybe we can come to the next question. Yes. Compute the kinetic energy of a particle of mass 2 kg having velocity v, 3t square I cap plus t cube j cap as time t equals to 2. So what will be the kinetic energy of a particle? So kinetic energy, first of all, kinetic energy T can have the expression half m v square, but as this is a scalar and v is a vector, v is a vector, so in scalar form I can write T as half m v vector dot v vector. Okay. So here m is given as 2 kg and v vector is given. So v vector is 3t square I cap plus t cube j cap. 3t square I cap plus t cube j cap. So I can write v vector dot v vector is 3t square I cap plus t cube j cap dot product 3t square I cap plus t cube j cap. So the answer is like 9 t to the power 4 plus t to the power 6. So our T, that means the kinetic energy, is half into 2 into 9 t to the power 4 plus t to the power 6. And they are asking at t equals to how much? T equals to 2. Okay. So 9 t to the power 4 plus t to the power 6 at t equals to 2. So if I simply write here 2 to the power 4, 2 to the power 6. So the answer will be 16 into 9 plus 64. So it is 208. Okay. So the kinetic energy for the particle is 208 units. Units basically is a unit, it will be, because it is given in kg. So you can see 208 units. That means the first one is the correct one. Okay. So how I did that? Compute the kinetic energy of a particle of mass 2 kg having velocity v at time t equals to 2. So v is given, m is given. So I am just calculating kinetic energy T equals to half m v vector dot v vector. So it will be something like one vector is there and another, the same vector would be there. So the dot product between these two will be calculated, and then we will put the t value equals to 2 second and we will get the v square value, and according to that one, half and v square, I will just calculate the value of the kinetic energy, and the answer is coming as 208 units. Okay. So the fourth question. A particle of mass 2 kg again has position vector r vector equals to t square I cap plus t j cap, and force acting on it is F. Find the torque at t equals to 1. Okay, so first of all, given is m equals to 2 kg. And what are given there? The position vector rt is given, which is t square I cap plus t j cap. And another one is given as ft. This is 4t I cap plus 3 j cap. So they are asking that what will be the torque. Torque is what? Torque is tau. Tau is r cross f. Okay. So r cross f. If I write here, okay, now I can do one thing, as there is mass is given, right? But torque is simply r cross f. So we don't need to use the mass here, but obviously there is no problem if it is given mass equals to m kg. That is also no problem, because it's just giving a additional information, that's it. But we are not, in this question particularly, we don't need the mass of the particle. We just we need the torque at t equals to 1. So for that, what I will do, r vector is given, a vector is given. So we will just simply do the cross product. So to do the cross product, we will just do like that. What is the value? T square t. T square t is 0. Then this is 43. 43 0. So you can see here, this is 0. J cap will also 0. Only k cap will be there. And For k cap it is 3t square minus 4t square. So it will be minus basically t square k cap. Now at t equals to 1, what will be the torque? The torque is minus k cap. Okay. So the torque tau equals to r cross f, which has the value minus k cap. Yes, the answer is 1 minus k cap. So how do I do that? First of all, here the position vector is given r vector, and the force is given f vector, and the torque they are asking, and torque will be r cross f, that means the cross product between r vector and f vector. So if I do the r vector cross f vector, then it will be something minus t square k cap. And if I put t equals to 1, that means it will simply give me the torque at t equals to 1 as minus k cap. So torque at t equals to 1 is minus k cap. Okay? Yeah. Okay, so fifth question. Yeah, so from the fifth question, basically we are basically getting into the central force problem, and Sir has already explained to show very well about the central force field and how we can calculate the orbit, like orbital equation of dynamics, and then he has calculated if I have the value of f, how I can get the value of the orbit, how I can get the equation of the motion for that particle, or if I have the equation of the motion, then how I can get the f value. All the things he has already calculated very well. So from this it's onwards the central force problem is coming. So what is the question saying here? If the speed, okay, so speed means like v is given, and v is telling that v is proportional to r to the power minus 2. So I can write it like this, and also simply I can write it like k by r square, where k is a constant. Then if the speed of a particle under a central force F proportional to r to the power n arises as r to the power minus 2, then n is what? That means our v is given as k by r square. Then what will be the form? Like what is the dependency of if r on r? That is the question. So question is given speed or velocity, whatever, is k by r square, then f of r proportional to r to the power n. What is n? This is the question. Okay. So for that, what we can tell, yeah. So our f, I can write it like this. This is the, or I can write, as it is a central force field, I can write it like that. F of r into r cap. Okay. Okay. So we will basically focus on that FR only. We will just focus on the magnitude, not the direction, because they are asking that how FR is varying with R. That's it. So for that, we know FR, I can write it is like ddt of mv. Yes? Or m dv dt. I can write it like that. Okay. Again, I can write one thing, that m dv dr dt. That can also be possible, right? So I can write m dv dr, then there it is v. So it is like mv dv dr. Okay. So our v dr can be written as v dv. dv can be written as m fr dr. Okay, so m fr v dv dr, fr v, no actually, sorry, that is m only divided by m. So I can write it here that fr equals to integration m v dv dr, right? So I have v as k by r square. So I have dv dr as minus this. So what is fr? Yeah, so what is fr? Fr is m v dv dr. So it is m then k by r square and then minus 2k by r cube. So basically we just need how fr is formed with r. So that means I can say here that mk then minus 2k is also there, but the main thing is that r to the power 5, because r cube is there, r square is there, r cube is there. So we can say that our fr is proportional to 1 by r to the power 5. So our fr can be written as r to the power minus 5. So our n has the value as minus 5. Okay. So if I see the option, that is fourth one. So how I did that one? So if the speed of a particle is given like speed v as 1 by r square, then we will just need to write the expression of f in terms of v and r, because v is a function of r. So we just need to write v in and r, and in terms of the expression of f in terms of v and r. So it is writing m v dv dr. So that means what? So simply m v dv dr. Okay, it is not correct actually. Yes, this will be there, m v dv dr. So then m v dv dr, and v is what? V is 1 by r, k by r square. So dv dr is what? Dv dr will be like the derivative of k by r square. So it will be like minus 2k by r cube. And then if I just multiply these two, then it is like k by r square minus 2k by r cube. They just need the dependency of fr on r. So I can see that fr is proportional to 1 by r to the power 5, and from that I can get n equals to minus 5. Okay. So this is the answer. Yeah. So now we will go for the next question. Yeah, this question is good one. For a particle moving under central force, the vector r cross l, where l is the angular momentum, is how much? Okay. Okay. First of all, this one. What is this? And l is angular momentum, right? And it can be written as l can be written as r cross p. Okay. So I can write it like r cross m v vector. Okay. And as it is given that this is in a central force field, Sir has already explained that it is a planar in motion. That means what? For v vector, I will only take vr and v theta component, right? as it is planar in motion. So planar in motion means we will just need to take the r component and theta component in my calculation. Yeah. So now r cross L means r cross P means r cross MV. Now if I write M outside, r cross V. Now what will happen here? First of all, V I can write it like V r cap plus V theta cap. So VR is what? VR is r dot r cap plus r theta dot theta cap. Okay? Because VR is r dot and V theta is r theta dot. So r vector cross V vector, what is given here? Okay? So that will be like r vector cross r dot r cap plus r theta dot theta cap. Now r vector I can write it like r cap cross r dot r cap plus r theta dot theta cap. Okay. Now you can see r dot r cap cross r cap plus r square theta dot r cap cross theta cap. Now you can see r cap cross r cap will give me 0. So r square theta dot r cap cross theta cap. This one I am getting from r vector cross v vector. But now I need M r cross v. So r cross v. That means I need r cross v, and r cross v I have already get it. So it is r cap cross r square theta dot r cap cross theta cap. So I have r square theta dot r cap cross theta cap. Now what is the value of this one? So there is a expression. If it is like that, then what will be the answer? This will be the law. A, B. Now in my question, it is like r cap cross theta cap. So I can write similarly by seeing these things. It is like B means r cap AC r cap dot theta cap minus C means theta cap r cap dot r cap. Now you can see that r cap dot theta cap is exactly 0 because both are orthogonal. So it will be simply minus theta cap, and that r cap is 1. So it is minus theta cap. So I can write it like r cube theta dot theta cap. Now I had another m left. Yes, here m is there. So the answer r vector cross L vector is minus, oh there was a minus, it should be a minus, m r cube theta dot theta cap. So my final answer is minus m r cube theta dot theta cap. check with the answer. Minus m r cube theta dot theta cap. Minus m r cube theta dot theta cap. So what I did in that question, they are asking that in the central force, what will be the value of r cap cross l cap. So for that l cap I know r cross b, and for r cross mb, and as it is a central force field, we just read it and write the v vector as in the planar motion, and for the planar motion, our v vector is vr and v theta. Two components will be there, vr and v theta. So what is the value of vr and v theta here? So the expression of VR is r dot and v theta is r theta dot. So we will just write the v vector equals to r dot r cap plus r theta dot theta cap. Now we just need to calculate this one, r cap plus r cap, r vector plus r vector plus v vector. So first we have calculated r vector plus v vector. Then the answer I will just do r vector cross this answer. So what is r vector plus v vector? R vector plus v vector means I just put this here. Then r vector means I can write it like r cap. Okay. So then this is the answer, like r vector plus r vector will give me r cap plus r cap will give me 0. I can write here r cap. This one we used. So then r cap cross theta cap. So r cap plus theta cap I just put it as it is. Then the answer is r square theta dot r cap plus theta cap. Then r vector cross r vector plus v vector. So the answer is like r cap, then cross r square theta dot r cap cross theta cap. So r square theta cap, r cap plus theta cap. So it is like minus r cube theta dot theta. Why minus is there? Because I just explained here, a plus b plus c is b, a dot c minus c a dot b. If I put r plus theta, it is like r dot theta minus theta r dot r. And r dot r both are unit vectors, so that means the answer will be 1. So minus theta caps. Then answer is minus r cube theta dot theta. Okay. So if I just match that one with my answer, so the answer is second one, minus r cube theta dot theta cap. Okay. So now we can go for the next question. Yeah. So next question. Next question is this. A particle of mass m is moving under a central force along the trajectory, and the trajectory is r equals to a 1 plus cos theta. Then what is the value of fr? Okay. So in Sir's lecture he has already mentioned what is the Bennett equation. This is like d to u d theta 2 plus u equals to minus f 1 by u divided by m a square u square, where h is what? H is like r theta dot square, which is a constant one. Sorry, r square theta dot square theta dot. Now our r is a 1 plus cos theta, and we have also get r equals to 1 by u, and r is given by a 1 plus cos theta. So what we will do? First we will calculate u. U is 1 by r. That means 1 by a 1 plus cos theta. Okay. Then we will do du d theta. So for that I can see here the answer is minus square minus sin theta. So this is sin theta divided by a 1 plus cos theta whole square. So this is du d theta. Now come to d2u d theta 2. d2u d theta 2. So this is dd theta of du d theta. So dd theta of sin theta divided by a 1 plus cos theta whole square. So answer is cos theta divided by a 1 plus cos theta whole square plus square 1 plus cos theta to the power 4. Sorry. You can do the mathematics and you can get the answer for this as it will be simply cos theta and then 2 sin square theta. Okay, so cos theta by 1 plus cos theta whole square plus 2 sin square theta a 1 plus cos theta to the power 3. And this is d2u d theta 2. Now what I will do? I will do d2u I will do d2u d theta 2 plus u equals to it is cos theta. Okay, cos theta by a into 1 plus cos theta whole square plus 2 sin square theta. 2 sin square theta divided by a into 1 plus cos theta whole cube. So this is u double prime, and then plus 1 by a into 1 plus cos theta. So if I simplify this one, 1 plus cos theta whole cube, so it is cos theta 1 plus cos theta plus 2 sin square theta plus 1 plus cos theta whole square. So the answer is 1 plus cos theta whole square, then cos theta plus cos square theta plus 2 sin square theta plus 1 plus 2 cos theta plus cos square theta. So if I simplify again, you can see this is 3 cos theta plus 1 plus 2 sin square theta plus 2 cos square theta divided by a into 1 plus cos theta whole cube. So this will give me 3 cos theta plus 1 plus 2 into sin square theta plus cos square theta. Right? So cos theta plus 1 plus cos theta whole cube. So it is like 3 by a 1 plus cos theta whole square. So I can write it 3a divided by a 1 plus cos theta whole square, and it is 3a by r square, which is 3a u square. So I am getting u double prime plus u, that means d2u d theta 2 plus u is 3a u square, and from the equation I am getting d2u d theta 2 plus u equals to minus f1 by u divided by am a square u square. So f1 by u is minus am a square u square into 3a u square. So f1 by u is proportional to u to the power 4. That means our f r is proportional to 1 by r to the power 4. So our fr is proportional to r to the power minus 4. So now come to the answer. A particle of mass m is moving under a central force along the trajectory r equals to a 1 plus cos theta, then fr is what? So it will be r to the power minus 4. So how I did this? So I just put r equals to a 1 plus cos theta. Then I need the value of fr. So our Bennett equation told that d2u d theta 2 plus u equals to minus f1 by u by m a square u square, which is r square theta dot equals to 1, SI constant. Then I just put u as 1 by r. Then du d theta calculated, and I calculated d2u d theta 2, which is d theta of du d theta. Then I calculated this one with d2u d theta 2 plus u, and which is coming as, after simplification, it is coming as 3a u square. Then d2u d theta 2 plus u equals to 3a u square. So I just put it here, minus 1 by f1 by u by m a square u square. Then f of 1 by u is proportional to e to the power 4, which is f of r is proportional to 1 by r to the power 4. F r is proportional to e to the power minus 4. So that's how I got the answer as some f r is varying as e to the power minus 4. Okay. Now coming to the next question. This question is good. Particle follows a spiral trajectory. R equals to 80 and theta equals to omega t square by 2. If a equals to 1 by 3, omega equals to 1. Find the approximate speed at t equals to 3. Okay? Okay. So what we will do? Given r equals to 80 and a is 1 by 3. Right? So if a equals to 1 by 3 and r equals to 80, then I can directly write r equals to t by 3. And omega theta equals to omega t square by 2, and omega equals to 1. So theta equals to t square by 2. Yes. So we have theta equals to t square by 2 because our omega is given as 1. Now what they are asking? They are asking that they are asking what is the speed, what is the appropriate speed at t equals to 3. So first we will calculate speed. How we will calculate the speed? Speed is basically v vector. I can write it like v r cap plus v theta cap, and the mod value of v is root over v r square plus v theta square. Now what is VR? VR is R dot, V theta is R theta dot. Now I have R equals to 80, theta equals to omega t square by 2. So simply I have dr dt, that means R dot is A, and d theta dt, which is theta dot, is omega t 2t by 2, which is omega t. And I have again A equals to omega 3, omega equals to 1, so R dot is 1 by 3 and theta dot is t. So I can have VR equals to 1 by 3, V theta equals to R theta dot, so R is 80 into t, so t square by 3. Now our V is root over v r square plus v theta square, and they are asking t is 3. So if I put the value of t equals to 3, let me do the in general form first. Vr is 1 by 3, that means 1 by 3 whole square plus, this is t square by 3, so t square by 3 whole square, so it is 1 by 9 plus t to the power 4 by 9. So 1 by 3 root over 1 plus t to the power 4. And t is given as 3 seconds. So I can write our v as 1 by 3 root over 1 plus 81. So if I calculate, it is like 3.018 or something. So I can write 3.02 approximately. So the final answer is 3.02. So for this question, what I did, I just take that r equals to 80 and theta equals to omega t square by 2, and a is given 1 by 3, omega equals to 1, so that means I can write r equals to simply t by 3 and omega equals to theta equals to t square by 2. Then r dot I can write and theta dot I can write. So r dot is 1 by 3 and theta dot is simply t, and then VR and V theta, VR is R dot, V theta is R theta dot, and R is 80, theta is omega t square by 2. So simply I can write V equals to root over R dot square plus R theta dot square. So VR is 1 by 3, 1 by 3 whole square plus t square by 3 whole square. The answer is 3.02 approximately, which is option number 2. Yes. Okay, so maybe I can give the same question to you people as it was already explained in the question number 7. So the question I can just read it. If a particle moves under central force F proportional to r to the power n along the curve r equals to a1 minus cos theta. In the previous question, r was given as 1 plus cos theta, but here r is given as 1 minus cos theta. Similar procedure will be there, and you need to calculate the value of n. So similar procedure means first you will just write a equals to 1 minus cos theta, r equals to a into 1 minus cos theta, u will be 1 by a into 1 minus cos theta. You will calculate du d theta. You will calculate d2u d theta 2. Then you will put d2u d theta 2 plus u, and the Bennett equation. You will have d2u d theta 2 plus u equals to minus f 1 by u by m a square u square. If you just calculate this one, you can find as a function of u to the power something, then f of r will be function of 1 by r to the power something. This something will give the answer. This is the n value. Okay. So I think it's exactly similar one as we have done right now for r equals to a1 plus cos theta. So if time permits, then I can calculate, or otherwise you can calculate by your own. So now we can proceed for the final question maybe. Yes, this one. The total mechanical energy of particle moving under central force F equals to k by r to the power 5 is. So by seeing the question, I can directly answer the answer, but I just need to explain a little bit on that. So here Fr is given k by r to the power 5, and what it is saying, it is under a central force. Central force means curl of F will be 0, and if curl of F is 0, I can write it like that, and F I can write it minus grad phi, or basically minus del V del R, something like that, as it is function of R only. Now as I can write it minus del V del R, so I can again find V, which is minus F dot dr. F is what? K by r to the power 5. K by r to the power 5 dr. So it is k r to the power minus 5 dr. After doing the integration, I am having r to the power minus 4 by minus 4 plus c. So it is like k by 4 r to the power minus 4, which is k by 4 r to the power 4. We don't need to put here the constant. So this is V. So I have V means potential energy at F dot dr, which is k by 4 r to the power 4. Now kinetic energy. This is simply half m v square. And what is V here? V is again Vr r cap plus V theta theta cap, as it is a central force field, planar in motion. So V square means V vector dot V vector. So Vr r cap plus V theta theta cap dot product with Vr r cap plus V theta theta cap. Now I can write it r dot r cap r theta dot theta cap. So my V square is V dot V r dot r cap r theta dot theta cap dot product r dot r cap r theta dot theta cap. So this is coming as r dot square plus r square theta dot square. So now my kinetic energy is half in V dot V means half m r dot square r square theta dot square. Okay, so total mechanical energy is kinetic energy plus potential energy. So it is like kinetic energy is given half m r dot square theta dot square plus v. What is v we are getting? V we are getting as k by 4 r to the power 4. So r dot square theta dot square plus k by r to the power 4. So now our total energy is this one. Now you can see the option. Okay, how I told that it will be very much simple to calculate by seeing the options. You can see for the first one, half m r dot square plus half m r square theta dot square, these are exactly same for all the options. Only the difference is in the v portion, and I have the answer as this one. So this one is the correct answer, k by 4 r to the power 4. So by seeing the option, I can just only need to calculate the potential energy. That is also only the one I need to do. Okay, so I'm just writing here the final answer. It is half m r dot square half m r square theta dot square plus k by 4 r to the power 4. And to get the potential energy, what I did, potential energy as it is a central force field, I can write F equals to minus of V, and then V I can write is minus integration F dr, and F is given by k r to the power 5. So in minus integration k r to the power 5 dr, and the integration is like minus k r to the power minus 4 by minus 4. So it is like k by 4 to the r to the power minus 4, and it is coming as k by 4 r to the power 4. So I am having option number 1. Okay. So now, as I think I have a little bit time to get the answer number 9. Okay. So I will just start. R is 1 by u into 1 minus cos theta. So du d theta is a 1 minus cos theta whole square into, as it is, minus a into minus, that means simply sin theta. So it will be minus sin theta divided by a 1 minus cos theta whole square. So if you calculate d2u d theta 2, this will be minus cos theta divided by a 1 minus cos theta whole square minus 2 sin square theta divided by a into 1 minus cos theta whole cube. Please check this one. Okay. So if I calculate d2u d theta 2 plus u, this will be minus cos theta 1 minus cos theta whole square minus 2 sin square theta 1 minus cos theta whole cube plus 1 by 1 minus cos theta. Then the answer is like 1 minus cos theta whole cube minus cos theta 1 minus cos theta minus 2 sin square theta plus 1 minus cos theta whole square. So after little bit simplification, you can get similarly 3a u square, which is nothing but 3a 1 by a 1 minus cos theta. So now you can see I can write d2u d theta 2 plus u is 3a u square, which is again minus 1 by a for 1 by u in a square u square. So I can write if 1 by u is minus m a square a to the power of 3a minus 3m a square a to the power 4. So it will be f of r equals to 3m a square by r to the power 4. So our fr is proportional to r to the power minus 4. And as our fr is simply fr r cap, so our fr is also r to the power minus 4 proportional. Now for this case m equals to minus 4. Now we can see that when r was a into 1 plus cos theta, then if r or if r both are r to the power minus 4. Now also if r 1 minus cos theta, then if r or if r both are same. So our answer is this. Now go to the option. This is minus 4. So this is the yes. I'm taking all the questions from the first to last. Now, this is the first question. The particle of mass 3 units has initial position vector this and initial velocity this. Of course, assuming the particle is this. What is the position of velocity of the particle at time t equals to 3 seconds? This work done by the force. The particle moving along the velocity from t equals to 0 to t equals to 3. Vector d dt, and the answer is inverse 258.75 units. Then in the next question, compute the kinetic energy of a particle of mass 2 kg. Velocity is given, so atom is the v dot v. So we can find as t equals to 2 is a range. Particle of mass 2 kg has position vector this, and force acting on it is this. So you need to calculate the value of torque as t equals to 1 minus k cap. Now question number 5. If the speed of the particle is given as 1 by r square, then what will be the fr dependency on r? So if v is k by r square, then we can just have that fr is like basically we just transform that fr in terms of v and r. So mv dv by dv dr. So then we can just calculate dv dr and v, and then multiply. Then we are getting 1 by r to the power 5. So I into minus 5 in this case. Now question number 6. For a particle moving under the central force, the vector I plus L is how much? So this is very interesting because we just need a vector analysis very carefully. And where AL is given, AL is like R cross P and P is MV. So R cross MV. So I just calculated R cross MV first. Basically R cross V and M is outside. Then I just did R cross, then that result. So R cross V is coming as like R square theta dot R cap plus theta cap. And R cross V is like minus R cube theta dot theta cap. So the answer is minus M R cube theta dot theta. Okay, now this is the answer. This is the question. Particle of mass M is moving on the central force along the trajectory R equals to A1 plus cos theta. Then if R is how much? So for that, I just use the Green equation. d2u d theta 2 plus u equals to minus f1 w by m a square u square. So here we just need to calculate u and d2u d theta 2. Then we will calculate d2u d theta 2 plus u. So the answer is coming as u to the power 4. F of 1 by u is u to the power 4. And the answer is r to the power minus 4. Then this one is particle follows a spiral trajectory. R equals to 80, theta equals to omega t square by 2. Then we can have the answer that what is the approximate speed at t equals to 3. So speed at t equals to 3 we can write it like vr v theta and r dot r theta dot. Then mode of v equals to v square plus v theta square. So we just put all the values and we are getting 3.02 approximately. This is option number 2. Yes. Now the ninth question is exactly similar as the 7th one. If a particle moves under the central force r a 1 minus cos theta. Then what is the value of n? This is the similar one where I can get this answer. Now coming to the fourth one. Fourth one is the mechanical energy. By having the mechanical energy, kinetic energy plus potential energy. And kinetic energy is same for all the options, but still we just calculate it by our hand, and it is exactly coming as half m r square plus half m r square Reynolds square. And the v is coming as k by 4 r to the power 4. So the answer is this one. Yes. Okay. So this is up to the week 3 questions, and we will meet in the next week. Till then, bye bye.